In our project, we decided that the enterprise has three branches, the main branch, the second branch, and the third branch. So the main branch and the second branch are located at the same country in different cities, so they are connected through a router via WAN, wide area network, and this router is connected to the internet service provider in that country. So those two branches are in the same city, at the same country. The third branch is located very far away. It's located maybe in another country, so it's connected to the other two branches via the ISP router or the internet. So it's a very small branch. It contains only few pieces and other networking elements. So this is the general structure of the network we designed, the enterprise we designed the network for. So the third part, I will explain the packet tracer file, the network implementation we designed. So since we have three branches, I will show you here where are these three branches. So let me just zoom out so you can see a more clear Broadway view of the network. So here is the main branch. If you can see, the main branch has how many departments? The database center, the management department, the finance department, and the engineering department. So in total we have four departments. Let me just go back. So here we have the data center, the management department, the finance department, and the engineering department. For the second branch, we have two departments only, the management department and the engineering department. So here is the second branch, the management department and the engineer department. For the third branch, let me just zoom in. Here is the third branch. So here, if you compare it, here the third branch is connected to the ISP router. The third branch, this is the ISP router, and this is the border router of the enterprise. So it's connected to the ISP router, and the ISP router is connected to the internet. This is our representation of the internet. So this is the general structure inside the packet tracer design. So let me go through each department in a little bit of details. So this is the first branch, which is the main. We have the data center. It contains servers that helps the business go on, and these are the three departments. For each department, we assigned a VLAN, a different VLAN. So for department 1, the management department, we assigned VLAN 10. And the other two departments also, for this, we assigned VLAN 20, and this one VLAN 30, which is the engineering department. So we assigned different VLANs for different departments for security reasons and also for privacy reasons, as we will explain later. So each department has PCs and IP phones. So we implemented voice over IP technology in this enterprise to facilitate the connectivity or the voice connectivity and communication between different departments and branches. So each department has phone, IP, and PCs. For the second branch, we have two departments. Also, we separated those two departments by two different VLANs. Here VLAN 100 and also VLAN 110. As you can see, the same structure. We have multiple PCs, multiple IP phones. So it's similar to the main office departments. So this is the two departments. Let's just go back for the data center in the first branch, which is the main. Here we have multiple servers, each serve different job. Let's start from the first one. The first one is a DHCP server. The DHCP server distribute IP addresses for the second branch. So the second branch IPs are from the DHCP server. For the IPs of the main branch, they come from this router. So this router has a DHCP service. It distributes the IP addresses for these three departments. For the second branch, we have DHCP server that will handle the IP addressing. The second, we have a DNS server for the whole enterprise. The third one is the management file transfer protocol server. It's designed for the first department, which is in the main branch, is the management for this department. So this department has its own FTP server. Likewise, in the management of the second branch, this branch has its own server. For the finance in the main office has its own FTP server. Likewise, the engineering departments in both branches, the main branch and the second branch. The last server we have the private enterprise.com. It is an HTTP server. It provides the whole enterprise with this web page, privateenterprise.com. The other thing that I want to explain is this region. This is the demilitarized zone. It contains 3 servers. Let me just zoom in on it a little bit. We have a mail server, we have a public enterprise, and we have a DNS. This one is a mail server, this HTTP server, and this one is a DNS. Those servers are designed for outer users to access them. So if any user from the internet want to access certain services from this enterprise, this is the only region he can reach. So we explained the first branch and the second branch. So the other thing I want to explain is the third branch. The third branch contains only PCs. It is small branch. It's for let's say border management, overseas management, and it's connected via this router to the ISP router. But for security reason, we created IPsec VPN tunnel for this branch to communicate with the other 2 branches. So the ISP doesn't know about the traffic that's coming from the third branch to the second and the first branch. So this is our internet representation. We created here an HTTP server. It's google.com to represent the outer internet. So this network is designed for this purpose, that we connected 3 branches, and those 3 branches have access to the internet. So this is the general structure. Detailed description for each service, the voice over IP service, and the IPv6 and the access control list will be delivered later by my team members. Last but not least, I will explain the routing protocols. Here for internal routing between these departments and the two branches. We used interior routing protocols, and for routing between the border gateway router to the internet, we used BGP to handle this process. So this is my part. The whole physical and the network structure is explained, and later my friends will explain each technology in detail.
Assalamu alaikum, and thank you Salah for your introduction. This is me, Tamim Alnethary. I will try to show you that this network is working as described by Salah. Let's check the basic connectivity. So first we will check that PCs in different departments are able to communicate. So if we send a message, for example, from this department to this department, as you see, it is successfully connected. And we can also send a message from the whole branch, from any department in the first branch to the second branch. As you see, it is also successful. We can also check the email connectivity between employees in different departments. So if we try to send a message from, let's say, PC30.1 to this PC100, so let's compose a message, for example, to PC100 100.1 at enterprise.com. So this is test message. This is, we send the message. Let's check that this message is received. As you see, it is received by BC100.1. Regarding the IP phones, as you see, we have a set of IP phones in each department. So we can check that the IP phones are able to communicate, employees are able to communicate in different departments. So this is this IP phone, for example, with this one. Let's check. So if we try to make a call, as you see, 35002 and 3500. Let's dial this number 35003. As you see, it is ringing, so I can answer the call. As we said, we can also check the communication of voice between the two branches or the branches. So let's try to call this guy, for example, which is 1001. This is in the second branch. So if we call 10001, it is also working. So this is regarding the basic connectivity inside the branches. And as we said, clients from outside the enterprise are only able to access the services provided by this enterprise through the demilitarized zone. So let's check that people from outside are able to communicate. So for example, if you want to access this our website, the public enterprise website, which is public enterprise from the internet, let's check. As you see, it is working fine. So there is also connectivity between the third branch, and also the more advanced things will be described by my friend Sami. So Sami, you can start. Thank you.
Assalamu alaikum, my name is Sami Albatati. Thank you for my friends Salah and Tamim. For security purpose, we have designed an inbound firewall that will restrict the outside networks from accessing the enterprise network, unless if they want to access the demilitarized zone, as Tamim showed. For example, we can ping from this PC, which we assume that this region is in the internet. We can ping from this PC to the any server in our demilitarized zone. However, we cannot access the data center, for example. It failed. And also we can show this in another way. We have two websites, the public one and the private one. The public one, it's in the demilitarized zone, so it can be accessible from outside network. Public enterprise.com, which is the domain name. Welcome to public enterprise. However, if this PC wants to access the private website, it should not be allowed. But for the PCs inside the enterprise network, it should be able to access both the public website and the private one. For example, this is the private enterprise.com. Welcome to private enterprise. Also, we have designed the access control lists because we have many servers in the data centers, and not all of them can be accessible from all the departments. Okay, some of them, like the private enterprise.com, the website can be accessible from all the departments. As you can see, it's successful. Also from the second one. But for example, if there are also FTP servers for management 1, which means the management department in the first branch, the management department in the second branch, and these servers should be accessible from only their departments. For example, this PC can access the FTP, management 1 FTP, because it's allowed to. However, if there is a PC in the finance department wants to access it, it should fail. Also, we have the management 2, which means the management in the second branch. We should be able to access the server successful, but if there is a PC in the management department in the first branch wants to access it, it should fail, and we can show the rest of them. For example, the finance can access the finance FTP server, but the engineering, for example, cannot access it. We have also designed the TCP access control list established. So the PCs inside the networks can, for example, access the Google server, which is outside the network. We allow the TCP from port 443 and 80 for HTTP and HTTPS to go through the firewall if it's priorly established. We can see, for example, that we can access Google. Welcome to google.com. However, if we want to ping from the Google server to the PC here inside, it should fail. only the DCP can go through the firewall, and if there is if it's priorly established, so if there is an attacker here, for example, even if he tries to access it and mimic that its port is 80 or 443, it cannot, because there is no session established. We have also there are 3 branches in the enterprise. The first one here and the second one here, and also we have the third branch, and we made it simple just to verify the IPsec tunnel. And this is one of the security purpose. We have designed the IPsec tunnel, so they the third branch, because the third branch communicates with the second with the first and the second branch through the internet. So we have designed the IPsec VPN tunnel to have a secure connection between the third branch and the main branches. So we can see that, for example, this PC can access the PC inside. It's successful. Also, it can access the data centers. For example, it's like any branch in like the first branch and the second branch. We can, for example, access the private enterprise. Welcome to private enterprise. When there is a connection between this branch through the IPsec VPN tunnel, the IPsec does not know about this network, and that's why, for example, if we want to ping from this PC to the ISP, it should fail. Let's do it again to be sure that it cannot. It failed because the ISP does not know about this network, but it can access from this one to also even it's successful to the second branch. And we can show that in the simulation mode. Okay, let's say we want to ping from here to here. Okay, we can see here in the inbound PTU details that what the ISP knows that it came from this public port 200.1, and it will go to this public port 100.1, but inside we know that it's from 3.10 to 10.13, and these are encrypted, and that's one of the security, that the data transferring between the third branch and the first and the second branch are encrypted, and we chose the AES 256, which means the size, the key size is 256, and also we can see that if we want to show crypto IPsec SA, that the packets encapsulation, encrypted, decapsulated, and decryption. So that's all. Thank you for watching. I hope we could explain our work clearly to you.